Hey guys, it's Mr. Chu, and here's what you're going to learn today. By the end of this video, you should be able to use the formula for the sum of a finite geometric series to solve problems. So with question 1, we're asked to determine how many terms there are in a geometric series, given the first term is 3, common ratio of 4, and the sum is 1023. So the formula we're going to use is going to be S sub n equals the first term times 1 minus r to the n divided by 1 minus r. And as a recap, each of these terms represents something different. S sub n, that's the sum. A1, that's the first term of your sequence. R, in this case there are two of them, that's your common ratio. And n is the total number of terms. So the information that we know is our first term, our common ratio, and our sum. We're trying to find out the n value. So let's substitute all the terms that we know into our equation. So our sum is going to be 1023, and that's going to be set equal to our first term, which is 3, times 1 minus the common ratio to the n power, because we don't know n, divided by 1 minus common ratio. Let's go ahead and follow order of operations. So we've got 1023 equals 3 times 1 minus 4 to the n over negative 3. What we can do is divide both sides by 3, and so we get 341 equals 1 minus 4 to the n over negative 3. Let's get rid of our denominator, so let's multiply both sides by negative 3. And so we get negative 1023 equals 1 minus 4 to the n. We'll add 1 to both sides. We'll subtract 1 from both sides of our equal sign to get negative 1024 equals negative 4 to the n. Then we can divide by negative 1 to get rid of the negative. And we get 1024 equals 4 to the n power. Now at this point, we're just trying to figure out what value we can plug into the exponent to get 1024. And we can check. So 4 to the first is 4, so that's not going to work. 4 to the second is 16, it's not going to work. 4 to the third, that's 64, it's not going to work. 4 to the fourth is 256, not going to work. But 4 to the fifth is 1024. So n equals 5. And that's it.